Good morning, class. Today we are going on to section 5.4 of logarithmic equations. Can you turn to your textbook, page 118? Page 118, we are going to go through logarithmic equations. Now I will go through the work examples to show you how do we solve log equations. Okay, now let's look at example 20, part A. It says log 3x is 2, which means this is the base, this is the power, this is the answer. So I rewrite it in index form. I will find that x is equals to 9. Okay. Now likewise for part B, I will rewrite this into index form, and note that half is to the power of -1 to the power of x, 2, 4. So you simplify, you will get your x as equals to -4. Okay, your x as equals to -4. Alright. Likewise for part C, okay, for part C, we also rewrite it into index form, okay, which is x squared equals to 4x minus 3. We form a quadratic equation, we factorize and we solve. Now, note that we have to check the answers with the equation, the original equation, okay. Now, log is only defined when this base is positive and this whole thing is positive. So when x is equals to 1, this is 1 and this is 1, this is positive and this is positive, but note that this base here cannot be 1. The log function is only defined, okay, the log function is only defined when y is positive and a is positive and a is not equals to 1. Okay, so since this is equals to 1, it is not possible, so this will be rejected. Alright, so that will complete your example 20. Now I'm going on to another concept that is on page 119. Okay, page 119. Now if we have log a m equals to log a n, that means m will be equals to n. That means if this is the same, this will be equivalent to this. Okay, now I'll give you an example. If I have this, can you see that this is log 3, this is log 3? So you can equate this to this and then you solve, and the answer is equals to 3. Okay, so that is the concept that is given on page 119. Now I'm going on straight into example 21. Okay, example 21. Now let's take a look at example 21 and see how are we going to solve the equation. Now remember the log rules, when it is a plus, we can multiply them and get this. So we have this, and I change it to index form. This is the base, this is the power, so I get this. I form into a quadratic equation, I solve, okay, then I will check. Now why is x equals to 2 rejected? Because when I substitute 2 here, I will get a negative value. I'll substitute 2 here, I get a negative value. So 2 is rejected. Now you can check with the, you must check, not you can, you must check with the original equation. Okay, now note, there's another way to do this. Alright, now I want you to take note that if log 2x squared minus 7x plus 12 is equals to 1, now I taught you before, 1 is actually log 2 because log a is 1. Okay, log a is 1. Alright, so if you put it in this form, this is log 2, you can equate the inside and it will fall back to the same thing. So this is another way to look at example 21 part A. Now I'm going on to example 21 part B. Okay, part B. Now this one I can bring up, I get this minus, so I can do the division. Okay, I put it into index form. Okay, index form. Okay, so you have p equals to this. P will be plus or minus 4. So this is 4 or negative 4. Note that the original equation, this one cannot be negative, therefore negative 4 is rejected. Okay, therefore negative 4 is rejected. Alright, so always check with the original equation. That is your example 21 part B. Okay, now I'm moving on to example 22. Okay, this is found on page 120. Okay, I'm going to go through example 22. Alright, okay, let's start. Okay, now you will see that this is log base 3 base 9 base 3 base 3. We got to change it to the same log. So I use a change of base formula. Same base, 4 put on top, 9 put below. I do this. Now I simplify, I get this. I bring the power down, I get this. Now class, note that log 3 is 1, so I will get this equation. Now because this is a plus, I can combine them, and because this is log 3, I can simply equate the inside here, get a quadratic equation and solve. Okay, now why is x equals to negative 2 rejected? Because when you sub in here, this is negative 2, which is not defined. But if you sub in here negative 2, this is a 2, which is defined. Now as long as one of them is not defined, you must reject. Okay, as long as one of them is not defined at the original equation, you must reject. Okay, alright, now I'm going on to part B. Now let's take a look at part B. Part B, we are going to solve for x as well. We will have this. Now we change this to base 5. This one put on top, this one put below, plus 3. I get this. Now, because of this, I let y be log 5x, which is easier. Okay, then I will replace this by y. I get a quadratic equation in y. Okay, but please remember, we are not solving for y. We are solving for x. So we got to write back. Okay, then we write this in index form. 5 to the power of 4, you get 625. 5 to the power of negative 1, you get 1/5. Okay, when you let something, you must know that y is not the answer, x is the answer. You must substitute back to get the answer to the equation. Okay, so that is your example 22. Okay, let's move on to the next part on page 121. That's example 23. Okay, now I'm going to show you this way, and this is a common way that we use to solve some of the exponential equations using log. Now if you look at this equation, there's no way you can put 21 to base 6. So what we do is that we take common log on both sides. Okay, then this power we can bring down. Then we have this. Then x plus 2 is log 21 over log 6. Then you bring the 2 over to become negative 2. Remember, LG is common log, and on your calculator, you press LOG in order to find the value. Okay, so you will get the answer as negative 0.301. Okay, now if it is to base E, you don't take log, you take ln on both sides. You bring this down. Now note that ln E is 1, so you are left with 3x this. Then you just key in the calculator, you will get 0.732. Now to key in ln, the calculator has this function ln. That's how you find the answer to example 23 part B. Okay, next we move on to example 24. Okay, now feel free to pause the video if you need time to take down notes. Now I am writing this in terms of base 4. Okay, so 2 power 2 is 4. Okay, so I have all this. Now you will see that this 2 has the same power. I will combine and become 12x. Now I bring the 5x over so that I can drag out the power to become 7. Okay, so we have already written this in the form ax equals to b. Then how do we solve for x? Now, because these are numbers, we take log, lg, okay? If it is in the form of e, then you take ln, alright? So, we do the manipulations, we key in the calculator, we will get 2.22. So, this is the answer to example 24. I repeat, if you have numbers, you take log, common log. If you have e, you take ln, the natural log. Alright, this is the procedure that we will follow. Alright, now I'm going to next give you your homework questions. Okay, your homework questions. Alright, but bear in mind that I will only go through some questions in the notebook. These are the notebook questions that you have to do. Okay, these are the notebook questions that you have to do. Okay, and these are the work that you have to do on foolscap paper. Now, it looks quite a bit, but actually it is essential practice for you. Okay, I will not cut it down. Please make sure you do all this on your foolscap paper. Now, I will pause for a while so that you can take down the questions, and I'm straight away going to go through some more difficult or more unusual questions in the notebook before I go on to the solution on the foolscap paper. Okay? Alright, for the notebook question, I will go through question 2b. I will go through question 2b. Now, why did I choose this question? I want you to take note. This is ln x whole thing squared. It is not ln x squared. Okay? If it's ln x squared, this can be 2 ln x. Using the power rule, you bring down the power. But this is the whole thing squared. It is not the same, therefore you cannot use this. You cannot use this particular relation because it is not correct. Okay, so what do? We take square root plus minus. We have ln x equals to root 3 or ln x equals to negative root 3. Ln is to the base e. I sub it in, I press the calculator, I'll be able to get the answer. Okay, so this is the solution to your 2b of your notebook question. Okay, I'm going to go through one more question in your notebook, and that is question number 14. Question number 14. I will not solve it in full for you, but I will tell you the relevant steps. Now, if you look at this particular equation, I can write this, because this is minus, I can put it into divide, and 36 over 9 is 4. Now, because these two are ln, I can equate this and this to get this. This is your equation 1. Now, for this, I just apply the rules of indices. I can get equation 2. Then, you will get the answer when you solve equation 1 and equation 2. Okay, you will get the answers when you solve equation 1 and equation 2. Okay, alright, now let me just give you the answer. Okay, you will get your x as equals to 3 and your y as equals to 5. Okay, that's how you solve question 14 of your notebook questions. Okay, next I'll be moving on to the foolscap solutions. Okay, class, please ensure that you have done your foolscap questions before you refer to the solutions. Okay, now I'm moving on. Let's look at question 6b. Alright, now for question 6b, you will realize that this is already log 2, so you just equate these two, you will get x equals to 2. This is quite straightforward. Okay, now for question number 3, question 7b. Okay, now first you bring the 3 up to be the power, then because it's the same base plus you times it, you get 144. Change it to index form, you will solve for x as plus minus 12. Okay, now you have to reject negative 12 because x cannot be negative over at the original equation. Okay, so that will be your 7 part B. I'm moving on here to 8 part C. Okay, let's take a look at 8 part C. Now, what is it talking about? Now, we have this and this. Now, I move this over and leave the 2 behind. Minus, so is divide. I will have this. Then I write it in index form. I form a quadratic equation and then I solve. Now, this time round, we do not reject negative 1. Why? Let's look at the original equation. If x is negative 1 and negative 1 here, I have negative 2, but when I square it, it's positive. So the logarithm is defined. Even if I put negative 1 here, I get a 1. So it's still defined. So you do not reject negative 1. So you must always check with the original equation before you decide whether to reject or not. Do not anyhow reject an answer. Okay, next I'm going on to 9b. Alright, I'm going on to question 9b. Okay, let's look at 9b. Now, for question 9b, alright, I am going to change all to base 3. Now, this one, if I change to base 3, is log 3, 3 on top, x below. Now, don't forget, log 3 is equivalent to 1. So 3 times 1, I have 3, I remain like that. Now, I let u, because question 9 says to let u be log 3x. So I replaced, I get a quadratic equation in u. But be careful, you are not solving for u. You are solving for x. So I have to put it back, put it in index form, and I can find the value of x. So that is your question 9b. Alright? Now, I am moving on to question number 10. Okay, question number 10. Let's look at 10a. Alright, let's take a look at 10a. Now, what you do is that we write all into index form. Okay, now let me check something before I continue so that it is clear to you. Okay, let me just check something from the textbook. Okay, I'm correct here. Change all this to index form. 2 to the power of negative 3 is 1 over 8. Therefore, you solve, you will get negative 7 over 16. Okay, now next we look at part C. Let us look at part C. Okay, 10 part C. Now you again change it to index form. Okay, and then you solve. Now don't forget, after you solve, you have to plug it back to the original equation to see if it works. Now for part A, if you plug this in, this is still positive, so it works. For part C, you plug both in, it will also work. So all the answers are okay. Alright, next I'm going on to 11e. Let's look at 11e. 11e, alright, this is how we solve it. Okay, we will change this because you cannot key in this in your calculator. So I change it to log base 10. This one put on top, this one put below. Like that, you can key in the calculator and get the answer. Okay, you need to do a change of base in order to key in the calculator. Now, some people will ask me, what if I change it to ln? Okay, even if you change it to ln, you will still get the same answer. It doesn't matter. Okay, now if you don't believe me, you can try pressing your calculator. The answer is still -1/4, so it doesn't matter at all. Okay, next we will look at question 11. Okay, now question 11a. 11a. Now we have this. Now it's multiplied. Now when it's multiplied, you cannot multiply these two because the rule is for plus. Okay, the log rules. Let me write for you again the log rules. Alright, the log rules says log ax plus log ay is log a xy. Alright, it is not times, it is plus. So plus, then you can times. This is a times, there's no rule for this. So what you do is that you leave this here and bring the ln 2 over. Then you write it into index form. Ln means base e, this is the power for x. So you bring the 4 down, you key in the calculator, you'll be getting 18.9 as the solution. Okay, alright, so that is your 11a. Alright, 11a. Okay, that is the solution to question 11a. Now I'm going on to 11b and c. Now 11b is this. Alright, 11b is this. Okay, now you will know that this is to base 10, so I have 10 raised to this power. I get this, then I plus 2. I'll key in the calculator, I'll get this value. Okay, now let's take a look at part C. It might look a bit difficult here because it is a little bit complicated. So I'm going to explain now. Now ln, you know that is to the base e. So e, this is the power. E to this power will be 4x. So x will be this divided by 4. So you key in the calculator, you will get 0.349 as the answer. Okay, alright, now next question. Question 11d. Okay, question 11d is slightly easier. Now can you see that both are in terms of common log? So I just need to equate the inside and I will get x equals to e squared, because -1 plus 1 is 0. You get 7.39. Okay, that is your 11d. I'm moving on to question 13a. 13a. Alright, I want you to take note here. Now, ln e is 1. Why is it 1? Because it's log ee. Log ee is 1. So, I write it in terms of index form. 2 to the power of 1 is 2. I get the answer as 9. Okay, alright, now next, 13b. 13b. I have this whole thing. Okay, now mind you, log 1 is 0 and this is 1, therefore I get 0 plus 1, which is 1. So 2 to the power of 1 is this. So x is 3 squared, I'll get 9. So the answer is 9 for 13b. Okay, now for 13c, okay, looks terrible, but let me simplify it for you. Now let's take a look here. Can everyone see that this is log 4? Since this is log 4, I can equate these two together. Okay, then I write this in index form. This one stays here, 3 to the power of 2 is here. Now we know that 3 to the power of 2 is 9. I write another time in index form. You get 2 to the power of 9. The answer is 512 if you key in the calculator. So this is writing in index form twice, and also the first part is to equate inside because this is already log 4, which is the same. Okay, do not panic when you see a lot of things, just simplify it step by step. Alright, that will be your 13C. 13C. Now I'm moving on to question 15. Okay, question 15. I will show you how to form the first equation. Okay, the first equation. Now basically we are just writing all into base 2, simplifying and equating the index. So I get this first answer. Okay, equation 1. Now for the next part, I am using log 2 minus means divide. Okay, I write it in index form. Then after that I cross multiply, I will get this answer. So right now you have equation 1 and equation 2. So what are we supposed to do? We will solve them simultaneously. Solve them simultaneously, and you will get Q as 3/2 and P as 6.5. I will not show you the solution to the equations, how to solve it, because you already know how to solve this kind of simultaneous equation. Okay, that will conclude your question 15. Now I'm going on to question 16. Okay, 16 looks quite horrifying, but actually it is not. Alright, so let's take a look here. This is 2 log 5. Now I got to change everything to log 5, so x put on top, 25 put below. I will get this. Now how did I get this as 2? Because log 5 25 is log 5 5 squared, is 2 log 5 5. Now don't forget log 5 5 is 1, so that's why I get the 2 down there. Okay, now then I let y be log 5x, I get this, and I solve, and I replace back log 5x equals to 2. I write it in index form. I will get 25. Okay, I will get 25. Alright, that is your 16A. Now I'm moving on to 16B. Let's take a look at 16B. Okay, I'm also changing base first. I'm changing all to log 2. Log 2. So I have this. Okay, now log 2 4 is actually 2. Alright, I'm just going to repeat one more time how I do it. This is log 2 4 is log 2 2. So this is 2 log 2 2. Log 2 2 is 1, therefore it is 2. Okay, so this is how I get the 2 here. Okay, now then I multiply by 2 throughout, I get the equation. Okay, now this one is already log 2, so I just equate the inside here. I will get a quadratic equation and I solve it. Now after you solve, you must plug into the original equation, and you realize that negative 2 is actually rejected. Okay, negative 2 is rejected. Alright, okay, I'm moving on to 16 part C. Okay, 16 part C. Okay, now the manipulation are the same. I change everything to log 5. Okay, this one, if you bring the half down, log 5 5 is 1, I'll get half. When you divide by half, it's the same as times 2, so you get this. Okay, you solve, equating this and this, because these two are already the same. So you solve it, you get x equals to plus minus 1. Now remember to check back with the original one. Now even if x is negative 1, this is positive. If x is negative 1, this is also positive. So there's no need to reject anything. Both answers, plus minus 1, are accepted in this particular question. That is your question 16. Okay, now I'm moving on to question 17. Alright, Now question 17 is quite unique. It says that solve for y in terms of x. That means they want y in terms of x. Okay, now I'm going to change everything to base 2. Okay, because plus minus, I times and I divide, I get this. I do this, I bring the power up. Okay, this is already log 2, so I equate this, I get this. So this is already the answer because y is in terms of x. Okay, that is your 17a. Alright, that will be your 17a. Now next, look at 17b. 17b looks terrible, okay, but I'm going to explain to you step by step. Okay, now let's take a look at 17b. We change to base 3. Okay, we bring the power up, then we simplify. Okay, now how did I get to this? Log 3 square is 2 log 3, so this guy actually becomes 2, so it's actually half, so it becomes half over here. Okay, then I do the necessary manipulation by bringing up the power and so on, and then I equate this. Alright, now y, this is 3 to the power of 2. To get rid of it, I take 2 to the power of 3 on both sides. So I take 2 to the power of 3. 8 is 2 to the power of 3 as well. Okay, alright, I repeat now. For this case here, what I do is this. I take 2 over 3 on both sides. 2 over 3 on both sides, because this one will give me 1 on the left side. That's why I must take to the power of 2 over 3 on both sides. Okay, so finally I will get this answer, and y is actually equals to 4x power 4 over 3. Okay, take some time to go through the solution to 17b. Alright, now remember, for this part here, I'm taking power 2 over 3 on both sides so that I can make this equals to y. Alright, okay, now next question will be question 19. Okay, question 19. Now let's take a look at question 19b. Okay, now I rewrite it. Okay, I rewrite, I bring it over, I drag the power up, I take log on both sides, I bring the power down, and I can solve for x. Okay, alright, now part C is the same thing. I rewrite it into this form. Okay, then these two have the same power, so it's x to the power of x, 6 to the power of x. This is 3/4, 21. I'll bring the 3/4 over, I'll get this. Then I take log on both sides, bring the x down, I'll get the answer as 1.86. So that is your 19C. Okay, now I'm going on to question 20. Okay, question 20. Let's take a look at question 20. Alright, question 20, I have to rewrite everything to base 3. Okay, I have to rewrite everything to base 3 because the question says form a quadratic equation in 3x, 3 power x. So I let y be 3x, I will get this. This is a quadratic already. I solve it until here, but 3x equals to -1 is rejected because no matter what value of x it is, it will never be negative, so it's rejected. So I am left with just this part to manipulate. Alright, so I take log on both sides, I bring the x down, and I key in the calculator to get the answer as 1.26. So that is your question number 20. Okay, now next is question 21a. Question 21a. Alright, we have to do a substitution. Now you rewrite everything in EX first, then you let y, okay, let y be EX because the question says so. So replace, get a quadratic and solve. Okay, now because it's E, you take ln. Now when you bring the x down, now don't forget ln E is 1, so you have this, so you just key in the calculator. Likewise for this side, don't forget ln E is 1 because ln E is the same as log EE. The answer is 1. Okay, you will get your answer as 1.39 for 21a. Alright, next I'm going on to 21b. Okay, now this one looks complicated, but let's do it slowly. Now first of all, you replace all the EX by y, you will get this cubic. Now you can factorize y out, you get a quadratic. So you factorize further, so you'll get 3 answers. Y equals to 0, y equals to 2, y equals to 1. But don't forget, you're not solving for y, you're solving for x. Okay, so you have this, this, and this. Now e to the power of x will never be 0. Okay, e to the power of x will never be 0. Alright, so that's why this is rejected. And after that, we take ln over here, bring the x down, then you get this answer. E to the power of x is 1, 1 is e to the power of 0. So x is equals to 0 because we are equating the powers. Okay, so x is equals to 0. Now e to the power of x will not be 0 because when we have the graph of e to the power of x, this is y equals to ex. Y will never be 0. This is actually the asymptote. That's why y can never be 0 or ex can never be 0, because y equals to 0 is an asymptote here. Okay, so ex is 0 is rejected because look at this ex, the y value, it can never be 0. The y is just approaching 0, but it will never touch 0. Okay, alright, so this is 21b. Now 21c. Okay, let's look at 21c. Now if you have problems with 21b, please look through the solutions again. Why I rejected e to the power of x equals to 0 is rejected. Now if let's say you're still confused, you can do this. Ln ex is ln 0, x ln e is ln 0, x is ln 0. Now if you key in the calculator for ln 0, they will give you error. Therefore this one is rejected. If you are not sure why is it like that, because you see, class, this is a very important concept. That's why I'm saying it so many times. This one is y equals to 0. The equation of this line is y equals to 0. And this is y equals to ex. Now can you see that they will never meet? They will never meet because this line is an asymptote. Therefore ex equals to 0 does not exist because it doesn't have a point of intersection. Therefore this one is rejected. Okay, so this is explained in detail to you. Okay, alright, now next, 21c. I'm also replacing by e to the power of x with y. Now after you replaced, you will realize that you have a square root. So what we do is that we take square on both sides, we simplify into a quadratic, and then we solve, and then we replace the ex back, okay, to get the answer. Okay, how I get this x, I think you should know. I bring x down, and ln e is 1, therefore it's x. Bring x down, ln e is 1, therefore I have x. Okay, so this is the answer to question 21c. Okay, next question is question 22. Now question 22 they ask you to write it in the form ln x equals to ax plus b and find the exact value of a and of b. They want the exact value. So let's take ln on both sides. Bring the 3 down. Okay, now ln e is 1, therefore I have this. So ln x is this. That means ln x is 2x minus 1/3. I rewrite this. So if you compare, a will be 2 and b will be negative 1/3. These are the exact values for a and b. Okay, these are the exact values for a and b. Now next, if you look at part b, it's a bit tedious. Okay, now let's take a look here. You also take ln on both sides. Okay, you take ln on both sides. Then because it's times is a plus, I have this. Then you bring the negative x down, you have this, you get this. Okay, now don't forget ln e is 1, therefore it becomes x. So you have this, and then you rewrite in this form. Now when you compare, your a is actually 1 and your b is ln 2.46. Because they want the answer as exact value, you leave it like that. Okay, do not go and press the calculator because they want the exact value. Okay, now I'm moving on to question 23b, which is the last question. Okay, now I rewrite everything. Because this, I can combine the power x, 5 bring over the other side. I take log, bring the x down, and then I press the calculator. That will conclude your 23b. Okay, your 23b. Now class, feel free to replay or rewind or pause. Okay, if you need to clarify any of the questions. Okay, so that is all for your section 5.4 on logarithmic equations. Thank you.